Hi, this is Coach Chuck on behalf of the National Free Flight Society Youth Development Program. We're going to present a short video today to help both you and the event supervisor to get the most out of a remotely administered Right Stuff or Electric Right Stuff event, whether it's a video submittal or a Zoom submittal. This information is also helpful for an ES trying to run an event to make sure you have the right equipment and can get the job done. Our goal is to reduce the check-in time, especially online, and the workload for the ES during the check-in process. Our target audience is the team entering and the coach as well as the team, because the coach is responsible for acting like an ES during remote submittals. I apologize for my condition today. I just had shoulder surgery, so in a bit of a pain and not able to change my shirt into the NIFA shirt today, so we'll go with that. The first challenge for the remotely administered event is that we need the gym height. And this is the height to the nearest obstructions, whether that's lights or girders or the ceiling itself. The reason we need this gym height is because the performance of the Right Stuff and Electric Right Stuff is highly dependent on the available gym height. And so to try and level the playing field for different gymnasiums, we have a gym height correction factor available, and that factor is based on real data from real planes with this year's design. But that means you as a participant need to accurately determine your gymnasium height. So the first easiest way to do that is to get a laser distance finder. This particular one I like is from GearBest. It unfortunately takes about a month to get because it's coming from China. It's about $23 plus about $5 shipping and handling, which may be a little steep for a one-time measurement of a gymnasium. We like to bring this to any event we go to verify the ceiling and obstruction height so that we can adjust our rubber or our charge based on the actual height and not the published height. You can also get something very similar to this from Amazon for about $20. I'll put the link in the video here. That again is going to be the quickest, most accurate way. When you turn this on, you get a screen, and the top indicator here shows it's measuring from the bottom of the device up to the ceiling. You'll set that on the floor and then make sure the laser dot is where you want it on a beam or whatever your obstruction is, and then you'll press the button, the main button, and it'll read the distance in feet or meters, depending what your particular event is calling for. This device, I like it because it also gives an angle indication, so you can use it for the height not directly above you if that's needed. But it does take a month to get. I'll put a link to one with good reviews from Amazon for about $20. That's your best way to do it. The second best way is by providing a photograph of a known object height in the gymnasium. And that photograph should include the floor below that object, the top of the object itself, and the ceiling. And what we do is we take a photo with our camera phone, and we want to be very careful to have the phone vertical so that the image plane in the phone is at the same angle as the wall or whatever you're trying to measure the height of. We'll walk through this procedure in just a moment here. The simplest thing if you're in a gymnasium is the basket rim, because we know that the basket rim should be at 10 feet height. You'll want to measure that. You can easily do that with a tape measure to verify the height. And now you need a reference point on the floor, the rim itself, and a reference point at the ceiling directly above the rim. And all three of those points must be in a vertical line. Otherwise, we get inaccurate results. This is an image that I took at our recent regional event. And the first thing you notice here is I've stepped back far enough that I can have the feet of the person under the basket itself, and this bar up at the top of the basket, all in my field of view. That's important. And the second important thing is the person's head is about the same height as my eye when I'm holding the camera. By placing this head very near the center of the screen image, that guarantees that my camera is being held vertically. It means we have a lot of space wasted on the floor in front of this person, but it gives me a vertical camera, which gets rid of the lens parallax effects. So what we need here is a video editor or a photo editor. I'm using XNView. It's a free software package. I'll leave a link for it. But if you watch down here, this X and Y, that gives the cursor position within the image in pixels. Now, we need 3 key points in this image. Let me zoom in first. This person, I asked them to stand directly under the basket. And so I know that their feet are standing right under the basket, and where their sneakers are, that's the floor. So with that position, I can read the Y height in pixels at 2470. That's the feet. Now I go up to the edge of the rim, place the cursor there, and the rim is at 1895. Now I need to slide my view up so I have the bottom of this bar. The lights are hanging at the same height as the bottom of the bar, but the lights are not in line with the basket assembly, and they're so washed out I wouldn't get an accurate measurement in there at all. So I'll place the cursor right at the bottom of this bar, and that reads at 763. So now I have 3 cursor positions, all on objects are in a straight line. Now these could be points that are on a wall. That would be convenient because you know that they're in a vertical line, but you have to have something of known height. That could be the height of a person. So you could take the top of this person's head as your reference point. In our case, we're using the height of the basket, but keep in mind that basket is not against the wall. So we need 3 points that are collinear. The best way to do that is have someone stand directly under the basket, and then it would be good if you marked where you're measuring that location on one copy of the image. Measuring that. You could also print out a copy of this image and just scribble on it where you're making your measurements as your reference. What we'll do is we'll ask you to turn in an unmodified electronic version of the image, and then a second one could just be a photograph of a printed copy where you're going to circle the person's feet, the basketball net, and your reference point representing the ceiling or the obstacle height in the gym. From that, we can calculate the height of the gym. So we use a quick sheet in Excel to calculate the height of the ceiling using the pixel information we gathered from the photo. You could do this in a calculator, but quick to do it in Excel here. First, we enter the pixel position of each of the objects we located. The feet where they touch the floor, we're at 2470. The side of the rim of the basket was at 1895. And then the ceiling, or the bar in our case, was at 763. Those are the pixel positions of the 3 points. Now we want to know the pixels relative to the feet. So for the rim, we take the difference between the feet and the rim, and that's the pixel count from the feet to the rim. And then for the ceiling, we take the difference between the feet and the ceiling or bar. And that's your pixel distance from the floor to the ceiling. This is from the floor to the rim. We know the floor to the rim is in feet, 10 feet. We have an unknown of the height of the ceiling relative to the feet or the floor. So now we can just do a simple ratio, and we're going to say the height from the feet to the ceiling divided by the height from the feet to the rim in pixels, and that's your ratio of your heights. And now multiply that by your known height, feet to the rim, and that gives you feet to the ceiling at 29.68 feet. I measured with the laser distance finder while I was there and measured just under 30 feet. So you can see this is a fairly accurate method as long as you have 3 points that are collinear and vertical. Again, the important thing is that all of these points, the feet, the rim, and the ceiling, in this case this bar, are all in the same vertical plane, and that your camera is held such that the camera pixel plane is vertical. And we do that by making sure the person's head representing our position here is centered in the field of view of the camera. So with that, we see that with a simple camera and a known height, we can measure the height of the gym. Now, if you're in a facility that doesn't have a basket, you can simply measure up, say, 8 feet, 6 feet, whatever, on the wall and put a line of masking tape on the wall, something that stands out, some blue tape, and then do the same process with that known height. Just report the known height, and again, take a picture, print it out, circle your reference points, the intersection with the floor, the height of the reference point, and the height of the ceiling, and turn that in a second image that's marked up. And then you can do the math, or you can leave it to the judges to do the math to calculate the effective gym height. So that gets us past the gym height question with relatively low cost. The next important thing to measure is the dimensions of your airplane to make sure it's not oversized. And at a contest, you're going to have a dimensional gauge, something like this, to place the plane in. You have the wingspan across the top, you have the stab span and propeller diameter here, and the wing chord and propeller or stab chord here. This was made fairly simply by printing out a paper template, taping it together where those X's are, and then gluing it down with your spray glue adhesive to a masonite board. It actually has a screw together section in the middle because I used this out of town at an invite, and I had to fit it into my suitcase. But this is a lot of work to put together for a one-off measurement of your plane for a video submittal. So we're going to go through a simple process that will allow you to measure your plane accurately and quickly. If you simply use a ruler, it's hard to see that on the video, and that ends up taking a lot of time. So what you're going to need is a metric rule, meter stick, or this one is actually a 2-foot metal ruler that was part of a device I got from Harbor Freight for under $10. So the nice thing about it is the 0 point, if I can get it in focus, is all the way at the end of the ruler. If you don't have a 0 at the end of the ruler, you can make adjustments. So you'll need that ruler at least 2 feet long. You'll need a single popsicle stick, and you will need, for right stuff, 5 index cards. For electric right stuff, 4 of these cards. So to prepare for measuring your plane, and you can do this at home, you're going to take your index cards, and across the top of each card, you're going to put what the measurement is. This is 45 centimeter wingspan, 28 centimeter stab span, 24 centimeter prop, 9 centimeter wing chord, and 7 centimeter stab chord. You'll put those across the top. And I will do my best here with my limited arm to set this up. Now we're going to take the popsicle stick, and we're going to firmly tape it to the end of our ruler. Remember, our 0 is at the end. You want to get this tight to the end, make sure it's perpendicular to the ruler, and pull the tape tight. I have 1/2 inch tape here, so I'll need 2 pieces. And this becomes our reference mark on our ruler. Now we're going to start at the largest measurement, and that is our 45 centimeter wingspan. We're going to come in here and lay the card right across on the 45 line, like that. Now you're going to tape this bottom edge where it meets the ruler, but not the side. You want to make sure it stays square to the ruler. Wrap the tape around. So now this can flip up, but this edge is right at the 45. You start with the largest and you work your way down to the smallest, and we'll see that in just a minute. So here we've completed putting our ruler together. We have the popsicle stick flush with the end of the ruler. If your ruler doesn't have 0 at the end, you could use another index card and line it up with the 0, or put the popsicle stick on top of the ruler. But just make sure 0 is 0. And then we start at the smallest is on top. So when we flip that down, we have the next largest. So we have 7 centimeters, then we have 9 centimeters, then we have 24 and 28, and finally 45 for the wingspan. The labels are to the left as you face the ruler so that they are closest to the point you're measuring. And now it's a very simple matter to show the judges, okay, this one says 7 centimeters stab cord, and you can show on the video that it's lined up with 7, this one's lined up with 9, and so forth. Very quickly show the judges that this ruler is set up, and then you're ready to measure your plane. Set this ruler up at home and you'll be ready to go. All right, here's our ruler with the paper tabs on it, ready for measurement. Notice I've taped to the table. We don't need the ruler being knocked off the table and bumping into the airplane and causing damage. At this point, you would the coach can show the ES that the ruler is set up per spec, and you would simply zoom in here and say, okay, the 7 centimeter stab cord is right on the 7 centimeter line. Notice the longer line is the number. 9 centimeter wing cord, same thing. 24 centimeter prop, same thing. 28 centimeter stab span, and the 45 centimeter wingspan. So at this point, you're ready to measure your planes. You've proven to the ES that your cards are set at the right width. Flip them all back down, and you'll start with the 7 centimeter stab cord, since that's the smallest. Okay, so first we'll measure the stab cord, which is a 7 centimeter slot here. And notice I'm putting the nose of the plane away from the ruler down the table there. And I slide the stab in, and it easily fits in the 7 centimeter cord slot. Now we're going to flip that card up to expose the 9 centimeter wing cord. And again, I put the tail away from the ruler, and I can slide the wing cord into that slot. You want to make sure that the card is flush with the edge of the ruler, because if it's not, you can get a bigger or smaller slot. So you want to make sure it's not at an angle. Now we open it up one more time, and we can measure the propeller 24 centimeter span. And that one is tight. We may have to trim that one. Flip it up, and we got 28 centimeter for the stab span. We just come in there, plenty of room. And finally, flip it up, and we have the wingspan.
We're going to drop it down between the popsicle stick and the cardboard. It fits just fine.
Let's talk a little about scales. One of the biggest issues we've seen is inappropriate scales. We're trying to measure rubber that weighs 1.5 grams and planes that weigh anywhere from 8 to 9.5 grams. A kitchen scale that's good to 10 pounds simply isn't going to cut it with 1 gram resolution. You're going to have to find a scale either at your school, in one of your households, or purchase a scale. Your other option is to scale something like this. This is sold as a lightweight kitchen scale, a reloading scale, that kind of thing. This particular one is good to 0.5 kilogram, 500 grams, or about a pound. That's a little high for what we're doing, but the important thing is we have 2 decimal places on our gram measurement. So our gram reading has 2 decimal places, and that's the minimum we consider acceptable to measure these small amounts. This is a 500 gram scale. I'd rather see a scale with, say, 100 or 50 gram maximum range, so we're not so far down in the noise on it. This particular scale, there's a number of them out there that look like this. I highly recommend a brand called Amir, A-M-I-R. I've had about 5 of them that I've taken apart and used to build torque meters, and I haven't had any problem with drift. Some of the cheaper versions will have issues with drift. The Amir version of this scale you can get for about $14 on Amazon. I'll include a link. You can find cheaper versions for about $10. But if you look at the comments, they tend to have drift issues, so buyer beware. The AWS, again, you'll find cheaper versions that look like this for about $20 instead of $30. But again, look at the comments. There's a lot of issues with drift, inconsistent readings, and so forth. So highly recommend the AWS or the Amir. You need something with at least 2 decimal places. Let's see, one other place you might look is if one of your team's parents is into coffee. They may use a scale like this for weighing their coffee beans. If somebody is into reloading ammunition, they may have a suitable scale that you can borrow. But for $10 to $14, you can get 1/100 of a gram scale. For $30, you can get a milligram scale. Either way will be suitable for this measurement. If you come with a scale that is only measuring to the nearest gram, the ES cannot tell if your rubber is within spec or not. Same with your airplane, and it could be a cause for tearing if you're very close and they can't tell from your scale. So it's important to have the proper scale to do the job here.
Okay, so now in order to weigh your plane, you don't want to set the plane directly on the scale because there's parts of it hanging on the table and you're going to get an incorrect weight. So what we're going to do is take a cup. Styrofoam would work better. Plastic's all I had. Place that on the scale, and we've cut a slot that's almost as wide as our motor stick on our plane. After the cup is on the scale, press tare and make sure that with the cup on there, you're getting a 0 reading on the scale. Now you can just drop the plane into that slot near the balance point of the plane, and we're reading 8.07 grams. So we're heavy enough on the plane. That's all there is to measuring the plane, but it's important to get it up off the scale using a cup. Another option that we've used before is a piece of foam. Say this is from a laser printer cartridge. And again, tare the scale with that foam on it, and then you can press the plane into the slot that you've made in the foam and put it on the scale. Make sure it's not touching anything. Got 8.04 grams. I didn't push down on the plane with it on the scale, but I pressed it into the foam block off the scale so I wouldn't be loading up the load cell in the scale. Set your plane aside, and the last thing we need to do is measure the mass of your rubber. The easiest thing is take that same cup that you had and place it on the scale, make sure it tears, and then find your first piece of rubber and simply drop it into the cup. 1.48 grams, so we're good to go there. Dump that back into your labeled bag so you know which piece is which. Put the cup back on the scale. You may have got some lube in the cup, so go ahead and tear it before your next piece of rubber. Sequence through all of your rubber like that. By using the cup, your rubber isn't spreading around the table and getting off the scale and mismeasuring. So that's it on weighing.
Now that you're ready to fly, I want to address one of the key areas of confusion during the flying process, and that is the timing windows for your flight. You have a pre-flight timed window, which is 2 minutes for electric right stuff, 3 minutes for right stuff, and then you have an 8-minute flight window. I've seen this misinterpreted by many competitors as well as ESs at every level of contest. So it would be good to go over that right now. So let's take a look at a quick drawing here. Here we have a 3-minute window in beige, and this window represents your pre-flight period. This is for right stuff. For electric right stuff, this would be 2 minutes, but the concepts are the same. So this window starts when the judge hands you your rubber motor, or in the case of electric right stuff, your charger. That starts a 3-minute pre-flight time period. The purpose of this pre-flight period is to keep things moving along so a particular team doesn't take up a lot of the judge's time. Now, during that pre-flight time period, if we launch any flight, be it test or official, we're going to call green official, red test, powered or unpowered, so just a gliding flight. Launch any test during that 3-minute window and you get the bonus. That bonus is intended to keep things moving along. But a second thing happens when you launch that flight. Your 8-minute time window starts. This is your flight window for the rest of your flights. Starts with any flight during the pre-flight time period and continues on for 8 minutes. Within that 8-minute time period, you can launch any number of test flights. Let's say this initial flight was an official flight that you launched during the pre-flight period. You can launch multiple test flights trying to get a problem straightened out in your plane, and then launch your second official flight anywhere in this 8-minute window. If you launch your second official flight within the 8-minute window, right at the end, it will be allowed to fly to completion outside the 8-minute window and you'll get your time. You may not launch any additional flights after the conclusion of the 8-minute window. If you had started the 8-minute window with a test flight and then later did a official flight, same principles apply. You might do many test flights and then do an official flight. If you get late in your test period, you've done a bunch of test flights, you're trying to do resolve an issue, and then you fly an official flight, and this takes you to the end of the 8-minute period, you do not get your second official flight. You have to launch the second official flight before the end of the 8-minute period. Now, let's say you did not, you got your initial flight launched at the very end of the 3-minute window. You still get your bonus, and that still triggers the start of the 8-minute window, and the same rules apply. You have 8 minutes to initiate both of your official flights, even if one of those official flights is what initiated your 8-minute window. Now, in the case that you get no flights off in the 3-minute pre-flight window, 2 minutes for electric right stuff, at the conclusion of that pre-flight window, your 8-minute flight window will begin and you will get no bonus. Then sometime during that, you start your test flights and or official flights. And same thing applies. You must get this final official flight launched before the end of the 8 minutes. You have an unlimited number of flights in this window, but only 2 of them can be official. If you fail to announce whether it's official or trim flight, it is an official flight. So basically, this 3-minute pre-flight will end whenever you begin a flight of any sort, and that starts your 8-minute flight window. One final thing to note, that these pre-flight windows and flight windows have no timeouts. So if your plane gets stuck and you need to recover it, or you need repairs, or it lands on the other side of the gym, the clock continues to run. There is no timeout for retrieval of airplanes or repair of airplanes. So today we've taken a look at a few of the areas that have caused some difficulty with the remote administration of right stuff and electric right stuff, including measuring the gym height, which is important for the gym height correction factor to level the playing field. The plane dimensional measurements, doing that in a quick and effective way that's not going to damage your airplane and is not going to slow down the process of checking in. And then finally, looking at the airplane and rubber mass and making sure you have the proper equipment to do that. This is one area you may need to purchase something, say up to $15 at Amazon, and I'll have links in the description. One final area to look at, an area I've seen at in-person events as well as online, is the verification of the ratings of the equipment used on electric right stuff. The rules require that the judges be able to see the ratings on the capacitor as well as on the batteries in the charger. So on the capacitor, when you glue that onto your airplane, make sure the rating is visible. That's your 5F number, and it's either going to be a 2.7 or 3.0 V for volts. So 5 farad, 3 volts. That's usually in one stripe down the side of the capacitor, and in many cases I've seen that edge of the capacitor glued to the airplane, and you can't verify the size of the capacitor. That would be a tiering violation, so be sure you get that exposed. The same thing for your batteries in your charger. The ratings need to be visible. Now, obviously, a AA battery, alkaline Duracell is easy to verify, but you need to remove the cover off the charger. We've seen some chargers that will hold 3 batteries, but have a spacer for the 3rd battery. So it's important that you take that cover off so the judges can verify that it's a 1.5 volt cell and there's only 2 of the cells in that charger. One final thing on the charger, if you look at the FAQs for electric right stuff, the charger has a very limited selection of components that does not include a switch. So if you have one of the earlier chargers that has a switch, you can't just disable that. You have to either remove it or get a new charger. I know J&H Aerospace is selling replacement chargers that get past that rules limitation. So be sure to show the details of your charger and your on-airplane equipment to make sure that that lines up with the rules. With that, I think we are ready to go fly. I think if you follow these simple steps, you'll be in a great position to very quickly get through the check-in process and get on to your flying. If you have questions, feel free to contact us or comment below in the comments. Thank you very much.